Are we live? Hey everyone, my name is Dayan. This is my first stream, and today I'm learning how to use and work with an Arduino. I won't be talking much, but if you have any questions, you can ask in the chat. Let's get started.
Two. And can you hear it? There we go. This basically means is, hey, a current can just flow through, okay? Because they're connected right here, as I said, vertically. So with that in mind, let's move to the next section where we're actually going to discuss about resistors. So see you in the next one. Now we're going to discuss about resistors. So what are resistors? Resistors are electrical components that are used to limit current. This is going to be important because we don't want to damage other components due to current overflow. Okay, so let's start from this simple diagram, okay? So right here, we've got the positive terminal of the battery. The longer side is the positive terminal, as you can see here. And the shorter side right here is the negative terminal. So current always flows from the positive terminal to the negative terminal. So it's going to flow like this, go through this resistance right here, and then go through our LED, lights up our LED, then goes back to the negative terminal. As I said again, resistors are used to limit current. Why is this important? So if we, let's forget about the resistance existing here for a moment. So let's say we connected directly to the current, and we put our LED. In this case, we're going to fry our LED because we're going to be using too much current. Okay, so we want to limit the amount of current that goes through because we don't want to damage our LED. That's why we're going to be using resistors. So right now, we're going to use Ohm's law. It's known as V is equals to I times R. V stands for voltage, which is measured in volts. I stands for current, which is measured in amperes. And R stands for resistance, which is measured in ohm. This is ohm. The symbol you see right here, it's OHM, ohm. Okay, so right here, to actually even give you a better and a clear analogy, let me bring my Arduino right here, and let me bring this close enough so that you guys can see the 5V. That 5V means that it's going to output 5 volt. Okay, so that's why I said 5 volt right here. So let me just place it right here, then current goes, and then we have our resistor. And by the way, if you don't know how resistors look like, they look like this. Let me bring the pack and let me show it to you guys. They look like this. Sometimes you might find a yellow one, but it's okay. Blue or yellow is the same thing. Okay, so we have our resistance right here. Let me place that right here, and we
And if
have
you don't
our
know, I'm
precious
using an
LED.
Arduino Nano
Let me
for
just place
this.
that right here. So right here, when it comes to LEDs, they have a maximum limit of 20 milliamps. So if we go over 20 milliamps, what's going to basically happen is we're going to fry our LED. So we don't want that to happen. How do we prevent it? We use this law. So right here, we have 5 volt that is going to be output by the Arduino. So we're going to say 5V is equals to, this is 20 milliamps is the maximum. The recommended one is 10 to 15 milliamps. Okay, it's 10 to 15 milliamps is recommended, but this is like the full maximum. So let's use 15 milliamps because we don't want to go over the recommended limit. And we have our resistor right here. Okay, so let's divide this. This becomes 5 or 15. And we have milli right here, so it's going to be times 10 to the power of 3. And we've got our ohm. As I said earlier, it's measured in ohm. So in this case, it's going to be 0.3 continuous times 10 to the power of 3. Okay? Ohm. So R is going to basically be 333 ohms. This does not mean we have to exactly give it 333 ohms, but rather we should give it a range of, let's say, 300 to a 400 ohm range, okay, of resistance for this current not to obviously overflow and, as I said again, basically fry our LED. We don't want that again to happen. Okay, so with that in mind, how do we, measure how much ohm resistance is? So we're gonna actually check it. So there are two ways to actually do it. The first one is we bring our resistor up close, okay? And what you need is a resistor color code. You can Google it if you don't have it on your kit or you don't have an Arduino, but this is just a resistor color code. So right here, I have it right here. So let me start from the first line. The first line is red. And if you look close enough, right here, first line of red means 2. So let me bring my Sharpie right here. Let me write 2 down. You got 2. Now, let's look at my second band right here. It's also red. You can see it, it's also red. The second band of red means 2. So we go 2 right here. Then I have my third one. If you can see closely, it's black. So when we look at it right here, when you look at the third one, it's what? It's 0. Okay? Then we have my fourth line. My fourth line is also black. So I go to the fourth one and it's a multiplier. So this is basically how much I multiply it to. So in this case, it's black. So it's times 1 ohm. Okay, so when you multiply it, it's 220 ohms. If you look even close enough, there's a fifth band right here that looks brown. This is just tolerance, and we're not going to get into it because it's not really important surrounding this level, okay? So, okay, with that in mind, we have 220 ohms of resistance. So you guys can check your resistor by basically looking at the color codes. Okay, there's also another way to actually do this. So in this case, we're gonna go back to using multimeters. So right here, we have our handy multimeter. Bring this to the code. Can you right here? Why is that so we can detect 200 something that 200 up? So we can connect it right here. And as you can see here, it says kilo ohms. So we have to say kilo ohms. When we do the math, this turns out to be 242 ohms, which obviously is not 220 ohms directly, but it's just very close to it. So we can use our multimeter and give it's up to you to decide. Anyways, see you in the next section where we're going to be discussing about LEDs.
Understanding data structures and algorithms is difficult. Don't worry, Log2Base2 can help you. With our animation videos, you can start visualizing.
In this section, we're going to discuss the last component that we're going to need to build our first project. They're going to be LEDs. So if you open your pack, they come in this shape and they come in all sorts of colors. Right here we have red, blue, green, yellow. So before actually working with LEDs and putting them in our project and working with them in the circuit, what we're going to basically do is we're going to check the science behind them and have a brief understanding of how they work. Okay, so let me begin right here with something quite more popular. So light bulbs. Light bulbs were obviously invented by Thomas Edison, and let's see how they work. Okay, so right here we have a battery right here, and it supplies current. So what basically happens is current goes through this coil and it heats it up so much so that it starts emitting light. In this case, it is red hot. When we add more volt to this battery, or a higher voltage battery right here that we're using, we're going to supply more current, basically making this coil heat more, and it will obviously going to emit more light. So in this case, it becomes white hot. So what is the problem with light bulbs, and why did we even need to replace them? Well, the problem is, fundamentally speaking, light bulbs are not light generating devices. They are heat generating devices, because the electrical energy that we're going to input, the current, is going to go towards heat. 95% of it is going to go towards heat, while only 5% of it goes towards light. So in this case, we're going to be producing excess heat and we're going to be wasting energy. So we don't want that to happen. That's why we have LEDs. LEDs change electrical energy directly to light energy. Okay, so LED, the long form is light emitting diodes. Light emitting is self-explanatory, as it just says light emitting, it emits light. What is the word diode? Let's check it out right here. So before checking out diodes, LEDs are something that we use day to day. We have LED TVs, LED bulbs, LED stripes that we put inside of our rooms to just decorate and all that. So LEDs are something that we use every single day. Okay, so what are diodes? Diodes are devices made from semiconductors. Okay, so we know conductors and we know insulators. Conductors are what? Conductors are materials that can conduct electricity. For example, we can take this wire. It's a conductor. Okay, so we have insulators too. Insulators are the ones that are incapable of conducting electricity. For example, let's take this pencil that is just made of newspaper. And in the middle, we have semiconductors. So they show the property of conductors and also insulators. So let's check them out. When it comes to semiconductors, they have 4 valence electrons. So let's take, as an example, let's take silicon. It has 14 electrons. When we arrange it, it becomes 2, 8, 4. So it has 4 electrons on the outermost shell. So it's obviously 4 valence electrons right here. So when we align 5 silicon atoms, we have 5 silicon atoms right here. Okay, so when we put them in such a way, they become stable. Let me explain. So at the center, the one with that is marked with red, is the center molecule, and it has 4 valence electrons. The electrons are represented with dots, as you can see here. Okay, so we have another silicon atom right here, another silicon atom, another silicon atom, another silicon atom. Okay, so one important thing that we see right here is the underlined dots right here. These ones are shared electrons. So electrons will be shared between this silicon atom and the central atom, this silicon atom and the central atom, this silicon atom and the central atom, this silicon atom and the central atom. So if we add up the electrons right here, we have 1, 2 right here, 3, 4. And we also have 4 that we already have right here, 4 valence electrons that we have from the beginning. So when we add 4 plus 4, it is 8. So in this case, it's stable. So it doesn't want to receive or give any sort of electrons. So in this case, it's not going to conduct electricity. Why is that so? There will not be free electrons to move, so current cannot flow. Okay, so it shows the property of an insulator right here. So right now, we're going to use a method called doping. And this is the method that actually changes semiconductors and just changes the game for semiconductors and actually makes them behave like conductors. So let me bring this right here. We can check it out right here. So earlier, if you would actually look at it right here, earlier we had 5 silicon atoms. Okay, and instead of having 5 silicon atoms, replace that 1 silicon atom right here. We're going to replace it with an atom that has 5 valence electrons. So it has 5 dots right here. So instead of giving 1, like every silicon atom right here, it gives 2. So we're going to have, instead of 8, we're going to have 9 electrons. We could even count it. 1, 2, 3, 4, 5. We have 5 shared electrons, and we have 4 valence electrons that we already have on silicon atoms. So when we add that up, it becomes 9 electrons. So in this case, it is negatively charged because it has excess amount of electrons right here, and it wants to give those electrons. So it's negatively charged. That's why it's called the N-type, N standing for negative. Okay? So right here, we're going to conduct electricity because we have excess amount of electricity. We have free electricity. We have that 1 electron that wants to what? That wants to move freely. And again, we want to go back to what? To 8 electrons. Okay? We want to be stable. So in this case, what do we want to do? We want to give electrons. So right here, it shows the property of a conductor. We can also use another method. In this case, we're going to give it 3 electrons. So we have 4 silicon atoms right here. The one marked with blue is going to be the 3 electron element. So right here, when we add all this up, we're going to have 7 electrons. We have 1, 2, 3 electrons that are shared, and we have 4 electrons that are, again, of silicon atom. So when we add that up, it becomes 7 electrons. So this will not contribute towards any shared electrons, this element right here that has 3 electrons. Okay, so in this case, we are positively charged. Why is that so? We have an electron deficiency. and we want to receive electrons because we want to achieve stability with 8 electrons. Okay, so it's called p-type. P obviously standing for positive. Okay, so this is what is going to basically happen, and one thing that we're going to finally need to check is this. Okay, so with that in mind, right here, we have N types right here that have excess amount of electrons, 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 and electrons right here, and we have the P type that have holes. So let me discuss the concept of holes and what they are. If you look right here, we have hole. A hole is basically an empty space where an electron should have been. So if there was, let's say, 4 electrons like earlier, like we had right here, exactly right here, we just put the electron. But right now we have is an empty space because we don't have an electron. So basically, holes are just representation of just empty spaces where an electron should have been. Okay, so right here in the N type we have electrons over electrons over electrons, while in the P type we have holes and holes and holes and holes. Okay, so right here we connect the positive terminal of the battery, as you can see right here, with the N type, and the negative end of the battery with the P type. In this case, what basically happens is from the electron actually going towards the holes, what's going to basically happen is they're going to start repelling each other. So this one is negatively charged and this one is positively charged, but they start to repel each other. So in this case, current will not flow. Okay, so we connected the positive with the N type and the negative with the P type. But right now, when we change the direction of the battery and we connect the negative with the N type and the positive with the P type, what basically happens is electron flows from the N type to the P type. So these electrons flow from the N type to the P type. So in this case, they're flowing from higher energy level to a lower energy level. Okay, so in this case, when electrons are flowing from higher energy level to a lower energy level, they're basically going to be releasing energy. And as you know, the rule of conservation of energy is neither created nor destroyed, but rather taken from one form to another. So when they release that energy, the electrons, they release that energy in the form of light. So when they move from higher energy level to the lower energy level, they'll be losing energy. And that energy that they're going to be releasing is going to be in the form of light. So right now, what basically happens is we directly change electrical energy directly to light energy. So we don't need to have, excess heat and all that like the light bulbs did. Okay, so you might be wondering then what is the p-type of, an LED look like then in real life? Because it matters like what part of the battery that you connect it to. So if you look at your LED right now, let me just bring it up close. To look at it right now, let me just actually get this. Okay, so if you look right now, if you look at your LEDs, the LED legs right here, they're not even. One is longer and one is shorter. Okay, so the longer one, if you look right here, the longer one is the positive and the shorter one is the negative. The longer one is the P-type while the shorter one is the N-type. Okay, so if you look right here, we're going to connect the positive end of the battery right here with the positive, the longer side right here, and the negative part of the battery with the negative terminal. Okay, so we're going to actually check the next section on how to actually assemble our components that we've learned so far. So see you in the next section.
As part of Experience AI, we're launching a new set of resources to help young people protect their data, understand misinformation.
So now we're actually going to be in the exciting section of actually building and assembling what we've learned so far. So we have our Arduino right here. We have our resistor, which is again recommended to be 300 to 400 ohms. We have our LED right here. We have a connecting USB right here, where I'm going to be connecting my Arduino to a laptop. And I have my Arduino breadboard right here, okay? And then I have my connecting wires, okay? So let me begin by connecting the Arduino with the breadboard. If you have an Arduino Uno, you don't need to connect your Arduino with the breadboard. All you need to do is a hole again, so all you do is, again, connect it directly to a connecting wire. Okay, so second thing I'm going to need to do, we're trying to build a circuit actually, so let me bring the circuit right here, okay? So we've got our Arduino connected. We want to connect it to the 5 volt, so let me go right here and let's breadboard. All you need to do is so let me begin by connecting the Arduino with the breadboard. If you have an Arduino Uno, you don't need to connect your Arduino with the breadboard. All you need to do is a hole again, so all you do is, again, connect it directly to a connecting wire. Okay, so second thing I'm going to need to do, we're trying to build a circuit actually, so let me bring the circuit right here, okay? So we've got our Arduino connected. We want to connect it to the 5 volt, so let me go right here and let's try to connect it to 5 volt. There's the 5V. Connect it right there to the 5 volt, okay? Let's say I put it around 25, okay? Just put it randomly on 25. Then now, what we want to happen is we want to connect it to a resistor. Okay, so let me bring my resistor right here, bring it right here, and let me just try to connect it a bit. You can see it. Okay, so one thing you notice is I connected it across. So as you remember, this row is connected, but these two rows are not connected to each other because they have a gap. As I told you guys earlier. So if I connected it, let's say, in the same row, okay, horizontally in the same row. Let me just make this a bit more thin. Let's say connected it this way, okay? If let's say the resistor is not connected properly, sometimes this happens, you have to push it in, okay? And if the resistor is not connected properly, what is going to happen is basically this type of circuit. We have our, again, Arduino right here and directly connected to what? To our LED. So it's going to fry our LED with the one that's happened. Again, so if I connect it abroad though, if I connect it somewhere where it's not connected, again, let me just make this a bit more wide. It's a bit of a hustle to even connect resistors, to be honest. So you guys can see I connected it abroad is current will flow like this from the 5 volt to the connecting wire right here, goes horizontally, and let's say it's not connected right here. What is going to basically happen is it's not going to what? Conduct electricity. So at the worst case scenario, if you connect it like this, is nothing happens. So the LED does not light up. It's not going to get fried, but it's not going to light up. All you need to do again is connect it properly and you're good to go. So we want to connect it what? When we're connecting the resistors, we want to connect it across. If not, we can even connect it vertically, okay? Because again, as I said, they're not connected. So we want this one leg to be on the connected side and one leg to be on the side that's not connected anyway with, the circuit. Okay, with that in mind, let me just bring my LED. And before actually doing that, we first need to identify, let me just make this a bit more wide. We need to identify which one is the positive sign and the negative side. As I've told you guys earlier, the longer side is the positive, and we want to connect it to the positive terminal. As I said again, the P type, okay? This is the P type. And we want to connect the negative side with the negative terminal, the N type. So we want the longer side to be the direction of the positive. So I have the longer side right here, and I want to connect it right here, as you guys can see. Okay, now finally, we connected our Arduino, current is flowing, we've connected our resistors, we've also connected our LEDs, the positive side and the negative again. So if you look right here, actually, this is the positive side, okay? If you look at it in the diagrammatically, it's positive right here, and we have the negative right here, okay? So again, it's going to go all the way right here and to the negative terminal. And how do we get the negative terminal in an Arduino is, let me go all the way, you guys can see it, there's a sign that says G and D. You can see it right here, G and D stands for negative or ground, okay? So if I put G and D right here, that basically means is negative. There's no other meaning towards it, all right? So I want to connect it to the negative side of my LED. So all I need to do is push this, and we're done building our first circuit. So right now, let me finally bring our connecting USB. So let me connect it to my laptop. Okay, then let me connect my Arduino. There you have it. We have our first up and running LED circuit. Let me turn off the light so you guys can see it better. So there you have it again. This is a simple circuit. What's going on? Oh, you see resistors that I was talking about earlier? Sometimes they disconnect when we move them again. And what happened was, again, it turned off, but our LEDs, again, were not fried, as I said again, because the current cannot flow through. Okay, so with that in mind, see you on the next project.
I'm actually gonna use this Arduino Uno because I know it bit better.
In our previous section, we built a simple circuit that lights up an LED. So let me bring you that right here. So if you look close enough, we used our Arduino as a power source, nothing more than that, something that outputs 5 volt. We only used it as something that outputs 5 volt, but also can output a voltage, a battery can. So in this case, we can build the same exact project if we have a 5 volt battery, okay? So instead of using Arduino as a power source, we can use a battery. Right here, I have a 1.5 volt battery, as is just found commonly inside of the remotes and all the things that we use. So I'm going to use a 1.5 volt. But this means that current is going to be less, okay? So voltage is directly related to current. So I'm going to have less current. Basically, the light is going to be a bit more dim. So to actually demonstrate that, let me turn off the light. Maybe then you can see it. If you cannot, let me just bring this paper right here and try to overlay it with the paper. Maybe then you can see it. Can you see it? Okay, there we go. And let me just turn it off and turn it on so you can see the difference. Can you notice it? There we go. It's very dim though. You can see it if it was actually in a dark environment. But anyways, this raises the question, why not use batteries instead of Arduino? Because when you look at batteries, they look more reliable, they're cheaper, and again, they're easier, far easier to just move from place to place. So they're more convenient. So when you look at Arduino right here, we have all these things. You really need to be careful with Arduinos. Not only that too, but they're really expensive relative towards a battery. So this raises the question, why Arduino? Why are we using an Arduino? So one thing you guys need to know about Arduino is Arduino acts as a power source, but it's just definitely more than just a power source, all right? So it is a power source, it acts like it, but definitely it is more than just a power source. Even by looking at these pins and looking at all these things that we have right here, we can see that it's just definitely more than a power source. We're only talking about the 5 volt right here. So when you look at all these things that we have right here, it is definitely more than a power source. So what is the purpose of an Arduino? Arduino is used to code our electrical components. For example, let's say I wanted to code this so that it turns on and off every second. So it's going to turn on for a second, then turn off for another second, turn on, turn off, doing it in a loop. Okay, so it's going to turn on for 1 second, turn off for 1 second, turn on for 1 second, turn off for 1 second, and keeps going on in a loop. So how do I do this using a battery? I have to physically come in right here, turn it off, turn it on, count a second, turn it off, count a second, turn it on, count a second, turn it off. And obviously, this is not coding. But with Arduino, we can set this up. We can set this up so that we can actually code it to actually make it blink. So we're going to turn it on for 1 second, turn it off for 1 second. We can do this using an Arduino. So Arduino, what does it do? Something important that it does is it lets us code our physical components. I'm sure you use websites and applications and they're coded digitally. So what if you wanted to code our physical components? For example, let's say we're working on a robot or some other projects. This is where Arduino comes in. This is where Arduino comes in and lets us code our physical components. So definitely Arduino acts as a power source, but it acts as an intelligent power source, all right? An intelligent power source that we can code, okay? So it's definitely more than just a power source. All right, with that in mind, let's check how to actually code our Arduino. So how to actually transfer code to Arduino. So see you in the next section where you're on my screen and we actually check on how to code using an Arduino.
Hey developers, join us for the biggest AI competition with over $10,000 in cash prizes.
So far, we've learned that Arduino is more than just a power source, and it can do a lot more, especially letting us code our electrical components. So to start, we'll just use text right here. Those of you who have a physical Arduino, all you need to do again is go right here, follow this link, and download the Arduino. You're going to download this Arduino web editor. So without downloading anything, you guys can just start coding to your Arduino. That's all you need to do, start writing code to your Arduino. So you guys can just search the code online and sign up, and you can use this Arduino web editor. So without downloading anything, you guys can just start coding. Coding to your Arduino. That's all you need to do, start writing code to your Arduino. So once you're done downloading the Arduino code editor, it looks something like this. There we go. It looks something like this. It has void setup and void loop. We're going to check what these means, and not only that too, but we're also going to create this blink project that I mentioned earlier of the LED earlier in the next section. Okay, so now what we want to do to write code to Arduino. Let me go to our code editor, and one thing you need to set up is go to our Arduino and choose our board and our communication port. Okay, how do we do it? We go and select the board that we're using. For example, let's say I'm using an Arduino Uno. I go to Arduino Uno and select it. Obviously, I'm using an Arduino Nano, so I'm going to go back to Arduino Nano and select it. So you're going to choose the Arduino board that you have right here. Once you're done with that, you're going to check the communication port that you want to use. Right here, I only have one communication port, so I only have one COM port. So I don't have to stress, and I can just continue and just say OK. But let's say we have maybe two communication ports. Let's say I have another communication port right here underneath, and you do not know which one to use. To know which one to use, all you need to do is basically plug off your Arduino. So I'm going to plug it off, and once I plug it off, it's going to turn off. The communication port is going to be off. So you're going to know which communication port is tied to your Arduino. Okay, there we go. Go back to touch OK. Then I'm going to need to write code. So this is a starter code. This is a code that always exists for every sketch. Okay, so this is going to be a code from the complex ones to the easiest project. They're going to contain void setup and a void loop. Okay, so what is a void setup? This is where we actually put our setup code, okay? And it's gonna run once. Importantly, it's gonna run once, okay? So we're gonna put our setup code right here, and we're gonna only run it once. Okay, when it comes to loop, we're gonna put most of our code and our main code right here, and we're gonna run it repeatedly. So we're gonna run it over and over and over and over and over again, okay? So let me go right here, and to basically notify that our Arduino what pin we're gonna be using, we're gonna use this built-in function called pin mode, okay? We're gonna use something called pin mode. All right, there we go. And we're gonna tell it what pin we wanna use. Right here, I have, again, from 2 to 13. I have digital pin 2 to 13, so I'm just gonna choose random number. Let me just choose 7 for now. So we're gonna use pin 7. Okay, then once we're done letting our Arduino know which pin we're gonna be using, we're gonna notify it of how we're gonna use it, okay? So we're gonna tell it if we're gonna use it as an input or we're gonna use it as an output, okay? So if we wanna use it as an input, we want to what? We want to receive data from the pin, okay? So when we wanna use it as an output, what do we wanna do? We basically want to send data. In this case, we're gonna send what? Electricity, okay? We're gonna send voltage. Okay, so we wanna use it as an output in this case. Once we're done with that, for every line, when we finish a code, for every line, we're going to finish it with a semicolon, okay? So one thing to keep in mind is, for all of you, is capitalization does matter. So you cannot write down pin mode, let's say with a small m. If I did that, and let's say I want to verify the code, that's going to show me an error message. So one thing you want to keep in mind is, every time, capitalization matters in code, okay? So it even matters for this output. Let's say I say output right here with no capitalization, with no proper capitalization, it's going to give me an error, okay? So capitalization is very important in coding. And let me just run this right now. I don't see any error. Okay, there we go. So I wrote this down properly. So what does this code do? It tells our Arduino that we're going to use pin 7. How do you want to use it? You want to use it as an output. So once we're done notifying our Arduino and we're done setting up our pin, we're going to go to our loop. Okay, so how do we tell Arduino if you want to give 5 volt and 0 volt? We're going to use something called digital write. So right here too, again, specifically, capitalization is very important. So what pin do we want to write? We want to write down pin 7 that we already set up right here. There we go. And once we're done with that, you want to tell it if it's going to be high or low. High means 5 volt, okay? High means 5 volt, right? You want to keep this in mind. So high just basically means what? 5 volt. Okay, then once we're done with that, what do we want to do when we want to make it blink? We want to what? We want to write down the same code right here. Again, capitalization matters. And put pin 7, and you've guessed it by now, we're going to use low. We're going to use low. So what is it going to do? We're done setting up our code once, so we're going to notify Arduino what pin we're using and how we're going to be using it. And once we're done with that, it's going to run this code as a loop. It's going to run it repeatedly right here, okay? So it's going to go pin 7, it's going to turn it high. It's going to turn it to what? To 5 volt right here. Turn to 5 volt. And then when we turn it to low, we basically turn it to 0 volt or off. 5 volt or on, okay? That's what we're going to do. So let me just do is verify the code right here in case we have an error. It's done compiling right here properly. And then what we do is upload it, okay? And we're going to upload it to our Arduino. But one thing I forgot to do is to set up our Arduino. So we need to set up Arduino. So one thing I need to do right here before even setting it up and wiring it, as I told you guys before in the precaution safety section, what I told you guys was to turn off our Arduino. First, we build our circuit, and then we turn it on, okay? Okay, so let me bring my red pin right here and attach it to pin 7. Wait, that's pin 2. Pin 7 is right here. Okay, there we go. Put it right here. Put our handy resistor right here. We want to put it at an intersection. There we go. Okay, then we need our LED. I'm going to need to know the big side is obviously the positive. There we go. And put that right here, the positive at the positive side. And then we're going to go back to our GND, or negative terminal. Let me go to GND right here. There we go. So I want to check again up close if I'm actually correct or I'm making mistakes right here. So I'm just going to bring it closer to myself and check it for myself. Okay, that seems fine. Nice. Okay, let me check the long side again. Okay, there we go. I'm correct. All right, I'm done checking. Now I can turn on my Arduino. Let me turn it on. Okay. I think it's the resistor right here. Okay, it was the resistor, so let me just touch it again. Okay, there we go. It's working now. But can you notice something? It's not turning on and it's turning off. It's just not blinking. We cannot see any blinking right here, can you? I cannot. So what is happening? So let's analyze our code. So what we did was set up our code. Everything seems fine right here. Everything seems appropriate. And then what happens is basically what happens is we digital to the right and we set it to high, then we set it to low, then we set it to high and low. And one thing you notice is it's going to go at a very fast speed. It's going to be really, really fast. Computers are really, really fast. So we cannot notice this with our naked eye. So right here, look at it. It's going to go high, then it's going to go low really fast, then it's going to go high again. It's going to, again, go on a loop, as I said again. So it's going to go high, low, very, very fast, but we cannot notice it. So what do we need? We need a delay so we can notice it. So we're going to need a delay. So we're going to do that. We're going to do is use this delay function. Okay, so when I say 1000, it's going to be 1 second. So it's going to capture it in milliseconds. Okay, so we're going to write down how much seconds that you're going to delay it in milliseconds. So we want delayed right here and put our semicolon after every line. There we go. And we want to put the delay right here again, delay of 1000. Then there we go with our semicolon. And let's run it again. So let me just verify it right now. Okay, then I'm going to upload it.
If you want to become a pro Python developer without having any prior knowledge on the subject, then join our 30-day Python.
So it's going to turn off for 1 second and turn on for 1 second. Turn off for one, on, off, on, and it keeps going on. So let me go on, off, on, off. So we basically build this. Okay, so one thing to keep in mind again is that we use milliseconds. So when I say 1000 milliseconds, it basically means a second. So it's going to receive in milliseconds. Okay, there we go. So we're done actually building this. So actually in the next one, we're going to check. So in the next section, we're actually going to check a few things about variables. Okay, so I have homework for you guys. So before moving on to the next sections, you're actually going to do these homeworks. Okay, so what we did right now is obviously create this blink again. So we used one pin and create this blink. So what I want you guys to do is create a traffic light. So we have our green color right now. We've got our orange one, and we've got our red one. Okay, so we used one pin. Pin to set up everything for one LED. So how many pins are you going to be using for 3 LEDs? You're going to be using 3 pins, okay? So you're going to be using 3 digital pins. So you're going to put green and in front. So instead of actually the red one, green is going to be right here. Then we're going to have yellow, and then we're going to have red. Okay, so we're basically creating a traffic light. So I want this to do is basically, okay, what I want this to do is I want this to delay for 5 seconds and then turn off. So it's going to be on for 5 seconds. Okay, then when this one is off, obviously it's going to turn yellow. For this case, yellow is a shorter one, so I'm going to choose 1 second. And red, I want to make it the same as the green light because that makes sense. So we're going to make this 5 seconds too. Okay, so I want you to create a traffic light, a working traffic light. Okay, so you're going to be using 3 pins, creating a resistor right here, using the resistor right here, then obviously lighting up your LED, then going back to GND. Okay, so they're going to be using the same GND. So if I bring, let's say, a second wire, one thing you guys don't know is, let me just bring another wire. Okay, there we go, another wire. So let's say I have my ground right here of the second LED, of the yellow one, let's say, for example. And what you're going to do is connect to the same GND, okay? So you're going to connect to the same GND, it's okay. But you're going to be using what? Different pins, though. You're not going to be using the same pin. You're going to be using 3 totally different pins. So you might be using D5, D7, D8. It's up to you. So yeah, you're going to be building this project for yourself. So before moving on to the next section, so pause this video and work on it. If you are not sure of how the circuit is supposed to behave, again, you guys can use a digital simulator, okay? Afterwards, I'm actually going to build it with you guys. In case you do not know, you can refer back to the next section where I'm actually going to build it.
And we're back in third quarter planning. Adams is quarterbacking this project, and she is looking pretty tired, Jill.
She's stuck, Bill, and that deadline is looming.
Okay, so now we're actually gonna work on our homework. So I'm not gonna bore you guys out trying to that you guys need is that green is connected to 7. So the green pin right here, the green LED, sorry, the green LED is connected to what? The digital pin 7, okay? So it's connected to what? The digital pin 7. The same goes for yellow. It's connected to the digital pin 4, while the red LED is connected to the digital pin 9, okay? That's the necessary information that you guys need. So now let's code this. So first, we're gonna need to do a pin setup. So we're gonna need to go to pin mode and obviously set up our pins. So we wanna let Arduino know what pins we're using. So let me just copy this right here. Paste this, and we're using pin 4, so let me write down pin 4 right here. 4, we're using as an output. Yes, we are. Let me again paste this, and we only have pin 9, so we're going to use pin 9 here too. Nice. And once we're done with that, once we're done setting it up, let me just remove this code right now. Because we're not going to be using this. We're going to digital write our pin what? Our pin 7 for green. So we want green to light up first. So I'm going to go for pin 7, and I want to set it to high and finish it off with a semicolon. Then I'm going to copy this again. Copy this. Then I want what? I want pin 4 to be high. But before that, before actually going to 4, what do I want to do? I want to delay it. Okay. I want to delay it for how many seconds? 5 seconds. So it's going to be 5,000 here. So I'm going to be using milliseconds here. 5,000. Then I want to do what? I want to turn it off. Okay. So I want it to be low. So let me go here. And I got pin 7 here. Then I want to set it to what? To low. Okay. That's what I want to do. Okay. When it comes towards the yellow LED, what do I want to do? I want to do is the same thing almost, but I want to change the delay to what? To 1 second, don't I? So let me see it right here. Let me set this delay to how many? 1 second or 1,000 milliseconds. And I want to change the pin number again. I want to change it to 4. So go 4, and I'm going to go 4 again. Okay. This is for what? Let me just write this description down or comment. Yellow. This one is for green, so let me write down green right here. Green. Then I want the red one. It's going to be the same exact thing, but I want to change the pin with the green. Just copy that again. Do that, and I want to change the pin number to what? To 9, okay? All right. So I think I'm done with this one, so let's check if it's actually going to work. So let me verify this. Okay, seems like it's working. Let me connect my Arduino before uploading it. So let me go here, connect my Arduino, and let's upload the sketch.
Need to run Windows on your Mac? Parallels Desktop makes it.
Okay, it says it's done uploading, so let's check it out. There we go. There we go, it's working. Nice. That's great and all. But if you look closely, let me go through. turn on my Arduino and run this. Everything should be working normal. Let's check it out first. Okay, so 5 seconds. There we go. All right, it's working really, really great. Okay, so let's say I have a problem. I have to wait for like 5 seconds. And I just say it's just
So this is it for today. If you also want to learn the about Arduino, you can also go to the channel. The name of the channel is Free Code Camp.